Whirling. I'm Jeremy Hansen. I'm going to be your instructor today, and today we're going to go over analyzing the incident, which is part of the hazmat system. Chapter 24. And first objectives are to explain the API process at the hazardous material incident, define a hazardous material incident, identify states of matter as they relate to the hazardous material, identify the 7 clues to the presence of a hazardous material, describe ways that transportation placards, labels, and markings indicate the presence of hazards of hazardous materials. Identify other markings and colors that indicate the presence of hazardous materials. Describe ways that written resources are used to identify hazardous materials and their hazards. Then we will also at the end do a quiz and then do a skill sheet number 1 over this, which will be over recognizing and identification, incident protection actions, and notification. First objective, explain the API process, APIE, we call it API process at the hazardous material incident. So there's 4 simple steps that they go along with that makes this the API process. And so A is analyze, P is plan, I is implement, and E is evaluate. So step 1, analyze the incident, attempt to understand the current situation. So like, what do you think analyze means? Like, as you're coming up to a scene, when does analyze start? Is it just when you show up?
When you get dispatched.
Right when you get dispatched, you hear what's going on, try to figure out from there, coming to the scene. Plan. So plan starts after you get everything analyzed, and you have to make a plan out of what you've analyzed so far. So the initial response, use information gathered to determine what actions need to be taken to mitigate the incident. Then step 3, you implement your plan. So whatever you've planned, you try to implement, and the response, perform tasks determined in planning stage and direct action to mitigate the incident. And then 4, they call evaluate. So evaluate the progress. So always monitor progress, always see what's going on. Like, you guys are working, so as a person off the side, you're always going to evaluate, make sure what they're doing, the operations unit is doing, is working. If it's not working, reevaluate, try to go back after it, and continue after that. Continue throughout the incident until it's terminated. So who can describe the API process as it relates to hazardous material incidents?
Analyze.
No.
Plan.
No.
Implement, evaluate.
Good. There we go. So the first 3, let's go back. So the first 3 are more what the awareness and operations people will be. The evaluation's more for, the chief that's off to the side that's gonna run the scene. Define a hazardous material incident, which is our objective 2. So what is a hazardous material incident? It is a substance that possesses harmful characteristics. The United States describes it as hazardous materials, or as for short, aka hazmat. And then Canada and pretty much all other countries call it all dangerous goods. So we're the only ones in the United States that call it hazmat. Or we also have, which I didn't have it on the slide, but there's a WMD, which is weapon of mass destruction. Can be used by chemical, biological, radiological, nuclear, or explosives. Pretty much anything potentially cause harm or mass casualty is a WMD. And then potential causes of hazardous material. Human error is probably one of the most leading problems. And then you got mechanical breakdown and malfunction, which is the second. Transportation accidents, container failures, and deliberate acts. So, and then deliberate acts, anybody figure what that means? Sabotage, so like the WMDs, like
Terrorist.
terrorist activities, or there are chemical suicides. People take themselves out plus try to take others out as well. Then you got hazmat incident complexity. The hazmat identifies incidents are often more complex than all other types of emergency incidents. Often hazardous materials, WMDs, are involved in fires, explosives, and criminal or terrorist activities. Present a variety of changes, sometimes in small quantities, be extremely difficult to contain or control, require specialized equipment, procedures, and PPE. So a lot of it, like just our normal bunker gear, will not sustain. You'll have to get class A's or class 1s. Be difficult to detect, require sophisticated monitoring equipment. So hazardous material incidents are not always clearly defined before first responders arrive. You must be consistently alert to the presence of hazardous materials and their possible effects on the incident. Whether involved or not, the mere presence of hazardous materials may change the incident's dynamics. So that's just a caution. How do hazmat incidents differ from other emergency incidents?
Often more complex.
Yeah. What do you think would make them more complex?
There's more stages to it.
Yeah.
It's gonna have more people involved.
More people, more
different specialties,
Yeah.
people.
probably bigger evacuation zones and stuff like that. Now we're gonna go identifying the different states of matter as they're related to hazmat materials. So, states of hazmat materials. Uncontrolled release from a container can create many problems. Materials' physical and chemical properties affect how it behaves, determine the harm it can cause, influence the effect it may have on all its contents, including like people, other organisms, other chemicals, and the environment. Influence how a container will behave if damaged or ruptured. First responders need to know how to collect hazard and response data to provide information that the substance, physical, and chemical properties, so they can use that data for future reference. Proper resources can greatly assist in responding. Determine the present hazards, estimate potential harm, predict how the incident may progress. And then we're gonna go over the states of the different matter. So there's three. So we got solid, liquid, and gas. Okay, move that forward. So you got gaseous, liquid, and solid hazard materials behave differently, and it can show what it does. Like, so liquids, they like to pool or go down streams or flow downhill, right? May sink or float in water depending on their buoyancy. May release vapors. So if the liquid gets to its boiling point or whatever, it can start releasing its vapors and behave a lot like gas. Gas, indefinite shape, expands rapidly, may displace oxygen, travel quickly and easily, may rise or sink in air. And then you got solids, possibly reactive, will stay in place unless moved by air, water, or other force. Tiny particles may stay suspended in the air and may cause entrapment. So once you understand how the matters behave in each state, you can better predict where the hazard material is going, what exposure it may affect, what those effects may be. So after you know what they're gonna do, it's easier to contain or stop the potential hazard from moving on. States of matter will indicate how mobile the material may be, can help determine if there will be a far-reaching hazard property. So as in like gas is probably gonna be the hardest to contain. It's gonna move faster, way easier. So with knowing how those move or fast or whatever, you can help set up your control zones. So do you remember what our control zones are? Hot, warm, and cold, yeah. So, and also your evacuation distances. And then with these three, the emergency response guide established separation initial isolation distance based on the involved product state of matter. So it's kind of already got a predetermined, if you already know if it's gonna be liquid, gas, or solid. So if you got a solid, the ERG says initial is always gonna be 75 feet. If you got a liquid, they're gonna say it's always 150 feet. And gases, it's gonna be 330. That's without knowing what it is, you just know it's that matter until you get knocked down in that and realize what it is, then it'll give you a different footage on that. So what do we think the mobility is from least to most?
The
So-
solids don't move very fast.
So solids are probably the least, and then liquids probably,
Gas, yeah.
and then gas, yeah. And so the easier thing is to do is the solid, probably, to manage. And then substances can change state, depending on temperature, pressure, or direct. So, we've got propane tanks, we've all know, like, if you got heat rises, it's more likely to blow, right? Or pop off, or whatever you wanna do, so the pressure is up on it and it could expand. Temperature down, at least the pressure goes down. So we've all seen that thing where we practice the propane, shooting the water on it when it gets hot or if it's on fire to cool it down to keep the pressure down so it doesn't rupture or make a levy. So then we got gaseous hazmat. Incidents involving gases are potentially the most dangerous, which we said because it's the most fast moving. Many injuries due to inhalation and vapors or vapors or gases. So liquid can also kind of be involved with that because liquids put off vapors. But that's the most injuries is, it doesn't matter how protected your body is, if you don't have anything protecting your airway, then you're gonna get inhalation damage. And we know that gases may have odor, as in like chlorine. They got that chlorine's got a bad odor. May be colorless, odorless, or tasteless, as in like carbon monoxide. Maybe toxic, corrosive, or flammable. And then you got, so for like a corrosive, you got your ammonia, and like for a flammable, methane or natural gas. It may be under high pressure in excessive of 15,000 psi, such as the liquid helium, and may be extremely cold upon release, and or may have a large expansion ratio if liquefied. So, like, what would be extremely cold on release? Nitrogen or
Propane.
yeah, or propane could, yeah. So gases, which we've kind of hit on, gases may travel far. As a result, is difficult to contain or detect where they are not, where they may be going, especially the odorless ones. A gas leak in a building may potentially has many potential directions to spread. Depending on the ventilation or other factors, gas may spread throughout the building, to other buildings, through access shafts, into soil, into the streets where it will drift, wherever the wind may take it. So we kind of have an example like here, just kind of it's coming out of this and it's spreading through here. Or it can go out the window, spread in the street, spread to a neighboring building, or it can go up in a vanilla, like up the stairs throughout the whole building, or through the HVAC system or any systems there, and spread throughout the whole building. So gases are difficult, if not impossible, to contain for mitigation purposes. Compressed and liquefied gases, and then compressed liquefied gases expand rapidly, potentially threatening large areas, may require specialized detection equipment. If gases is invisible and or little or no odor, it may be impossible to detect without specialized detection systems or equipment such as combustible gas indicators or other instruments. Research has shown that 1 and 2 ton quantities of chlorine and anhydrous ammonia released in an open area may initially spread in a 360 radius before being dispersed downwind. So it could just cloud up before being pushed downwind and expand rapidly. If expanding gases can displace oxygen, creating an asphyxiating atmosphere. So we all know what asphyxiating is, right? Displaces your oxygen, takes it,
Can't breathe.
can't breathe. Hazards of gases. You got your breathing inhalation hazard and your contact hazard. So some gases may present either the contact or inhalation. In general, it has the potential to be much harder to mitigate. Also affect larger areas than incident involving other states of matter. And requires complex, difficult actions and protect responders and the public. So pretty much we just know gas is bad, hard to deal with. Liquid hazmat, usually visible, even if they're vapors or not. So it may be easier to detect their presence and determine the hazard area. Typically liquids do not travel as far as gases, unless they spill into a path or channel, such as storm drains, streams, rivers, or any other waterway that transports liquid quickly and efficiently. So we know, like, if we get a milk truck that tips over or whatever, it's got a liquid in it, and it can go into the ditches that go to the center creek, and that's a bad day, right? We can't get all that. Or even if it's just gasoline truck that tips over. Not only do we have to do that, but then we gotta worry about fire. But with those being said, we know there's gonna try to go downhill or in a channel, so it's easier to try to stop or contain the flow. Liquids will flow according to the contour topographic, or it gives first responders opportunities for contamination or confinement. Liquid can present a splash or contact hazard right here. So you can either get a splash if it's bubbling out, or contact if you're that brave to be that close to something that's spilling out of there. Liquid can be a unique challenge to first responders because they may take on an additional characteristics of gas by producing vapors. So you see the vapor hazard. If you get liquid can be unique, or as a conversion of liquid to vapor increase. Hazardous materials mobility challenge responders face when dealing with hazards. Vapors from liquid may travel like a gas through a typical, not as far from their source though. So it can become like gas, but it's typically not going to move like gas too far away from its source. It's just going to kind of cloud up and stay there. Be cautious and alert to vapors from liquids, as they may be contact hazard, inhalation hazard, flammable, corrosive, or toxic. So, like like we've said, vapors from liquids behave like gases and may be flammable, corrosive, or toxic. So now we're on to solid hazmat, the third one. Least mobile of the three states of matter typically will remain in place unless acted upon by exterior forces such as wind, water, or gravity. Particle size of solid, such as dust, fumes, or powder, may influence their behavior. Larger particles will probably settle out of the air fairly quickly. Smaller particles will probably stay in the air, be suspended, and move. Unit of measure typically used to express particle size is called micron. So they use microns to measure the particle sizes. Solid hazmats may have dangerous properties, as in like inhalation or contact hazard. You have small combustible particles that, if ignite, may explode. Entrapment hazard, kind of like this one here, where he's in a corn or a grain bin, and it's, even though it's small solids, it can still entrap you in that from sinking into it and then suffocating or getting crushed. Flammable, reactive, radioactive, corrosive, and toxic. Those are all solid, harmful actions. You can usually detect a solid visibly. May sublimate or sublime. Do you know what that is? Where it gets to a certain temperature, it starts kind of melting like ice. So that's sublimate or sublime. Usually confined to limited areas. Less likelihood of undetected travel. So solids are pretty easy to see. What are different hazards for gas, liquid, and solids?
Yes, moves very quickly.
Yeah, and it can be a big inhalation problem.
Solids don't.
Solids don't.
They tend to stay.
Yep.
So it's wind,
Yeah. But what are we most
They're
worried about?
measured in microns.
Yeah, you're good. But you're most worried about solids, as in around here, probably entrapment for grain bin or corn bins, or and then liquids. They're kind of in the middle because, well, they can travel in waterways and whatever, but they also can turn into vapor, which is kind of like a gas. Identify the 7 clues. Next objective. Identify the 7 clues to the presence of hazardous materials. Seven clues to the awareness level personnel and first responders must be able to analyze all incidents in order to detect and identify a presence of hazardous materials. Incidents involving hazmat can be controlled only when the personnel involved have sufficient information to make informed decisions. Time and effort devoted to identifying the contents of buildings, vehicles, and containers result in greater safety for first responders and the community. Failure to recognize hazardous materials as an emergency has caused unnecessary injuries and death. Once detected, once hazmat is detected, first responders can use resources to identify it and its potential hazards. With that information, first responders can initiate appropriate response action, perform them confidently. Some hazmat incidents or identification clues are easily visible at the distance, while others require responders to be much closer. The closer you need to be to identify the material, the greater your chances are of being exposed to its harmful effects. Distance often equates to safety. So, the 7 clues to the presence of hazardous materials. Here's kind of the 7 ways to see what they are. You got occupancy type, location, pre-incident survey. You got container shapes, transportation placards, labels and markings, other markings and colors, non-transportation, written resources, senses, and monitoring and detection devices. So they're also saying like there's different types of clues. Order of the clues also represent in general the increased level of risk to responders. So the different kind of detection device you have to use to get closer to the clue, the increase of risk you have. So if you have to get real up close and personal to detect that clue, higher risk. So, can we list the 7 clues?
The container shape,
Container shape,
Their placards.
placards,
any pre-incident surveys.
yep, pre-incident surveys, written resources, senses, monitoring, detection
Facilities.
services.
Type.
Yep, and facility, location.
Don't listen, we got you.
Hmm? We're gonna take a little 10-minute break. So I see some nodding eyes. Good with that? Yep.
Your schedule.
That's not our.
32 minutes.
Yeah. Huh?
32 minutes.
Yeah. That's what I'm going to.
Yeah, he's.
You guys ready for the long-winded stress report? Alright. So we're on to objective 5. Describe the ways that transportation placards, labels, and markings indicate the presence of a hazardous materials or hazmat. US, Canada, and Mexico use placarding, labeling, and marketing systems to identify hazmats during transportation. All 3 countries use the same source for their systems. The United Nations Model Regulation, also known as the Transportation of Dangerous Goods. The UN is recommendations. With a few country-specific variations, placards, labels, markings used to identify hazardous materials during transport are very similar in all 3 countries. So, generally speaking, labels are designed for non-bulk packaging, and some unique labels with no placard equivalent. Placards are designed for bulk packaging. Labels and placards look similar, convey similar information. There are certain unique labels for which there are no equivalent placards. Under the United Nations UN system, 9 hazard classes are used to categorize hazard materials. So we got class 1, explosives, class 2, gases, class 3, flammable liquids, class 4, flammable solids, substances liable to spontaneous combustion, or substances that emit flammable gases on contact with water. 5, oxidizing substance and organic peroxides. 6 is toxic and infectious substances. 7 is radioactive materials. Class 8 is corrosive substances. Class 9 is miscellaneous dangerous substances and articles. So you got, here's kind of what the UN identification placards look like, usually in that diamond shaped format. Also you have the, some of them don't have this, some of them just say flammable, and then you have the UN 4-digit unification number in there for each hazardous material. None of them ever go under 4-digit. They're always going to be a 4-digit unification number. Other displayed on placards, orange panels, and certain markings. In North America, these must be displayed on rail tank cars, cargo tank trucks, portable tanks, bulk packaging, table 1 materials regardless of quantity, certain non-bulk packaging, for example, poisonous gases in suspected amounts. Emergency Response Guide, ERG, provides a key to 4-digit identification numbers in yellow bordered section. If the 4-digit number is identified, first responders can use the ERG to determine appropriate initial response information based on material involved. 4-digit identification number will also appear on the shipping papers and should match numbers displayed on tank or shipping container exteriors. Common reference materials such as ERG do not list all 4 UN identification numbers. ERG does not list any numbers below 1,000. So, always 4, and they don't ever go under 1,000. NA North America numbers, also known as DOT numbers, are used by the United States Department of Transportation and are identical to UN numbers, except that some substances with the UN number may have an NA number. That additionally NA number used as image NA 8000, NA 9999. And then you got your placard breakdown. So you got your background color, the hazard symbol, the diamond shape. They're always going to be 10 by 8, 10.8 inches, hazard class, identification number, or hazard class identification. So shippers provide the diamond shape color for what they're transporting in their containers. Each hazard has their specific material hazard class. Materials hazard class is indicated by either its class or division, number, or name. Placards may be found on bulk packaging, rail tank cars, cargo tank vehicles, portable tanks, unit load devices containing hazardous materials over 640 cubic feet in capacity, and certain non-bulk containers. So you got orange is explosive, yellow is an oxidizer / reactive, red usually means flammable, white is a health hazard like poisonous or corrosive, blue is your water reactive materials, and green is your non-flammable gases. So, I know we've all seen those on different things for sure. And then you got your symbols. May see containers with more than one placard indicating more than one hazard or product presence. Unfortunately, improperly marked, unmarked, otherwise illegal shipments are common and may include the incompatible products that convey local, state, and federal laws, and waste product shipping and disposed of without permit. And then they also have the hazard symbols, usually on the placard, describing those: explosives, oxidizer, radioactive, flammable, poison, corrosive, not flammable. So you got the colors, and then you also have the symbols. So then you got the different, this is how the warning placards look. You got your class 1 explosives, and then you got your 0.4, 0.6, 0.5, and explosives. And then you got your gases, flammable liquids, flammable solids. Class 5, use your peroxides or oxidizers, your poisons, your radioactive, your corrosives, and your miscellaneous, and then your dangerous. And then this is just like your limited marketing or quantity marking. Important facts to relate to placards. Placards not required for shipments of infectious substances. So infectious substance is the only thing that placards are not required for in shipments. Other regulated materials for domestic transportation only: ORMDs, materials of trade, which is MOTs, limited quantities, small quantity packaging, radioactive materials, white label, combustible liquids, and non-bulk packaging. Some private agriculture or military vehicles may not have placards, even though they are carrying sufficient quantities of hazardous materials. Military trucks don't have to have the placards on. Hazard class or division number corresponding to primary or hazard classes of materials must be displayed in lower corner of placard. So the division number, like 6, has to be displayed on a placard. Dangerous placard is for mixed loads. So dangerous just means there's a mixture of 2 or more categories of hazardous materials in it, and that require different placards. So that's where you just know if you see dangers, you're working with multiple things and it doesn't really identify to tell you what they are. Other than class 7 or dangerous placard, text indicating a hazard is not required. Text may be omitted from oxygen placard only if specific ID number is displayed. So they don't have the text on it like hazard, it just has to have the number like this on it. Drivers may have varying degrees of information about hazardous materials in their vehicles. So they can tell you on their like BOLs, which is bill of ladings, what they're actually carrying in there. If all they have is dangerous, tell you all the different types what they have. Containers may have placards even though appear to be empty until certified as clean. So even though there might not be anything in it, if that tanker has not been cleaned out on the inside, they can still have to leave that placard up there because it hasn't been tagged and certified as clean. More on the labels there. There's different, provide similar information as vehicle placards, but instead they're labels, so they're only 3.9 inches versus that 10.8 on the other ones. May or may not have written text that identify hazardous materials within the packaging. Class 7 radioactive labels must always contain text. So these ones always have to have some kind of text on them. Most labels for 9 hazard classes, subdivisions are essentially the same as placarding counterparts. So, except this one's interesting. You got the cargo aircraft only. So if that's stipulated on there, it cannot go on an airplane. So, like, because airplanes can take some of them, but if it has that plus that, it is not allowed on an airplane. So that's a different. So primary and subside labels, packages with more than one label have more than one hazard or product, contain primary or subsidiary label for materials that meet the definition of more than one hazard class. So there's one material in that, one thing in that, but they are labeled in both as a toxic and a flammable liquid. So they have to have both of those on those. We go to markings, which are different than labels. Descriptive name, identification number, weight, and specification. Includes instructions, cautions, or UN marks, or a combination of therefore required on the outer packaging of the hazard materials. So you have package orientation, if it needs to go up, like stay that side, keep away from heat, overpack, fermenting marking, so red or black, inhalation hazard, hot, all those different ones that have to be labeled on the outside of a shipping package. And most common one we've probably seen is like this, it has to stay up, or the ORMD. So hot markings for elevated temperature materials, so like thermal hazard, can ignite flammable and combustible materials. Elevated temperature materials can present thermal hazards in form of heat. First responders must be extremely cautious to avoid being burned, because working around these can increase the effect of wearing PPE due to high ambient air. And then US DOT definition, liquid phase at a temperature at or above 220. Liquid phase with a flash point at or above 100 that is initially heated or offered for transportation or transported at or above its flash point. Solid phase at a temperature at or above 460. So liquids, 220, liquid phase at flash over above at 100. So they usually keep it above that. And then then your solid phase at temperatures 464. How does the U.S. transportation or system of placards, labels, and markings indicate the hazards posed as a hazardous material carried?
By, names or colors or numbers?
Yep, names, colors, numbers, UN, the 4-digit UN number, or text. It can be the simple text as dangerous,
Corrosive.
or corrosive, or, yeah, radioactive. Good. And they're all pretty similar, aren't they? Like, you saw that it was almost repeating, like, placards are very similar to labels, and labels have, but placards and labels almost have the same markings on them. They're just changed up a little bit in different sizes. Moving on to objective 6. Identify other markings and colors that indicate the presence of hazardous materials. A number of other marking systems, labels, colors, color codes, and signs may indicate the presence of hazards. Materials, hazardous materials, markings. So other markings and colors. Markings may be found at fixed facilities, on pipelines, on piping systems, and on other containers. Other markings may be simple, the word chlorine stenciled in it, or, corrosive material, and stuck on the outside of a fixed facility tank. Complicated site-specific hazards, communication systems using unique combinations of labels, placards, emergency contact information, and color codes. Some containers may be marked with special information, as in like caution, stay away, or danger, do not enter, if the red light is showing. Some fixed facility container may have identification numbers that correspond to the site or emergency plan that provide details on the product, quantity, and the other pertinent information. So, all those you can see are different. Do not enter if the red light shown, chlorine area, and caution or danger. And then, Bob, you know what this is before we move on?
407.
Close. 704.
704.
So NFPA 704 system, you just head backwards, we're good. So this describes the 3 different levels of the NFPA's standard system for identification of a hazardous material for emergency response. Widely recognized method for indicating presence of a hazardous material at commercial, manufacturing, or other fixed storage facilities. Use is commonly required by local ordinances for all occupancies that contain hazardous materials. Designed to
Is that across the street?
We're pausing for emergency call at 14:01, and we're at a 1-hour mark.
Checkpoint 31, Orlando Fire. Medical law enforcement, 621 short leaf lane. 621 short leaf lane, cross the Downey Drive and Jason Place Boulevard. For a female having a psychotic break. Contagious scene. 1401.
That is over there, huh?
Yeah.
When you come back in, we'll just see that.
Okay, we are back from the emergency call, restarting our timer with 1 hour down, 1 hour into it.
Okay, so we were going over the NFPA 704 system, standard system for the identification of hazardous of material and emergency response. Widely recognized method for indicating presence of hazardous materials at commercial, manufacturing, or fixed facilities. Used as commonly required by local ordinance for all occupancies that contain hazardous materials. Designed to alert emergency responders to health, which is health. You got flammability and instability. Related hazards that present as short-term acute exposures resulting from fire, spill, or similar emergencies. Uses rating system from 0 to 4. 4 indicating the most severe and 0 indicating the least severe. So you got your blue, which is health. So blue will always indicate health in your 704 system. And then you have red for your flammability and yellow for instability. Ratings are raised on the diamond shape, markings, or signs. So apparently that diamond would be bad because they're all severe. So whatever is in that is bad. Alternative background for use. Specialized hazard location in 6 o'clock position. Right down here. The only 2 specialized hazard symbols are W and OX. Kind of like shown here. The special hazard symbols, W with a line through it, usually means usually reactive with water, and then OX is an oxidizer. So that's what that is down here on the bottom, that makes the bottom of the diamond. You may see other symbols in a white coordinate on old diamonds, so the older system might still be around somehow. You might see other systems old, but more likely those are going to be the only 2 you see, and they've phased out the older ones. The NFPA 704 system may be used differently in countries outside of the United States or outside of United America. For example, NFPA 704 symbol might be used on transportation containers. The NFPA 704 diamond will relay the worst hazard level in each category on site. These may not all be from the same material. So, everybody good with the 704 system? Yeah. Okay. Moving on to the global harmonized system. So, promotes US and many other countries have developed the globalized harmonized system as classification and labeling of chemicals. So, the United States and all other countries got together and decided to use this system for all chemicals. Promotes common, consistent criteria for classifying chemicals according to the health, physical, and environmental hazards. Encourage use of capability, hazard labels, safety data sheets, formerly known as material safety data sheets for employees. Other hazards, communication information based on results of classification. Key elements. Uniform classification of hazardous materials, substances and mixtures, uniform labeling standards, allocation of label elements, symbols, and pictograms, and signal words. So you got signal words and then the pictures again, and they kind of look like the placards, don't they? like flammable, oxidizers, explosives, corrosives. So that's part of the GHS system. The only different ones is like variety of health hazards. That's a different symbol there, or environmental hazards, or warning. So danger, most severe hazard category, and warning is the least severe hazard category. Hazard statement and precautionary statements and pictograms, product and supplier identifications, multiple hazards and precedence of information, arrangements for the presence of the GHS system, pretty much makes up the, you can see these also included on your safety data sheet on the OSHA's hazard communication standards. Requires employees to identify hazards in the workplace, train employees how to recognize those hazards, ensure all hazardous materials, containers, are labeled, tagged, or marked with identity of the substance contained, along with the appropriate hazard warnings. Does not specify what system of the identification must be used, may be determined by the individual employee, but they all have to, doesn't matter what, but somehow labeled on there. First responders may interact variety of different labeling and system or marking systems in their jurisdiction. Conducting pre-incident surveys should assist responders in identifying and understanding these systems. So what you just talked about, during the pre-incident, we can see what all kind of risks they have in their place and chemicals. And then you have hazardous material information systems, HMIS, commonly used proprietary systems developed by the American Coding Association in order to comply with the HCS standards. Utilizes numerical rating and color code systems similar to the NFPA 704 to convey relative hazards of product to employees. So you got developed by American Code, utilizes numerical rating and color code. And then you got Canadian Workplace Hazard Material Information, which we're kind of farther away from Canada. We're not really going to see these much. We shouldn't. By the time they have crossed over here, it should have changed to ours. Like the US, hazard required product to be appropriately labeled and marked, spells out the requirements for the SDS, safety data sheet, supplier and workplace labels most commonly used. So theirs looks like this. Two types of labels most commonly used is the supplier label and workplace label. Both will include information such as product name, statement that the safety data sheet is available. Other information will vary depending on type of label. And then this is the old, so GHS and WIMS, but old WIMS is being replaced by GHS. So pretty much the same, just they've classified them differently and put different labels on them. But the WIMS is being outdated now. You have Mexican Hazard Communication Systems, which hopefully we don't have to deal with much either, but theirs is set up a little different. Essentially adopts the NFPA 704. Employers can use alternative systems that comply with appropriate general caution systems or triangles. So, with that being said, safety symbols, we use a rectangle, United States, Mexico has a triangle, Canada has a circle. That's their different shapes. And then, well, this is the CAS numbers. So CAS numbers right here. This is looking at the WIMS or the NIOSH book. You got CAS numbers here. Often, numerical identifications are assigned to individual chemicals, compounds, polymers, mixtures, alloys, may be assigned to biological sequences. Over 1,000 substances and sequences are registered. Most chemical databases are searchable by CAS number, typically included on the safety data sheets and other chemical references materials, such as the NIOSH pocketbook, where this one came from. So this is a picture of the NIOSH pocketbook, but all chemicals have a reference number, a CAS reference number. Military markings used on fixed facilities, maybe on vehicles, but not required. Not uniform. For security reasons, not all hazmat will be marked. So this kind of shows the military markings. You got your Division 1 of mass explosion, and on down to non-blast. And then you got your wear full protection, to wear full protective clothing, set 3. So you got 1, 2, and 3 different divisions. White being less emergency, and your breathing symbol, apply no water, and on down. And then you got your supplement chemical hazards, nerve agents, the top harmful nerve agent to the least blister. So it's more of a harmful, gonna kill you nerve agent to just a blistering agent. And then you got pesticide labels. Labels include EPA or Canada PCP numbers, hazard statement, pictograms, precautionary statements, product identifiers, single word, or supplier identifications, right here on your pesticide label. The EPA regulates manufacturers and labeling of pesticides. Your pictogram symbols inside the diamond or red border denotes particular hazards. Precautionary statements describe recommended measures that should be taken to minimize or prevent adverse effects results from exposure to hazardous product, improper storage and handling of hazardous product. 3 phases cover preventive, response, storage, disposal, and product. GAH provides guidance of precautionary statements include the list similar to the EPA currently uses. Work to increase standardization, and that way everybody knows what's going on when they see that label. Good on that. Lower categories of classification in unclassified products will not require pictograms or signal words under GHS. The certain EPA, which we saw, so those just use the numbers, the colors and the numbers, so there won't be any signal words or pictograms on them. They'll just use the numbers and the colors. The certain EPA systems include a third word signalizing caution, which is used additionally to warning and danger. Inert materials and pesticides may be more toxic or flammable than a pesticide itself. And then other symbols and signals. Every facility may have its own symbol, sign, or markings that they've made up at that facility that they will have to familiarize the responders in that district with. Caution contains PCBs. Attention to PCBs. These are just showing you the different, the Canadian label versus ours. Ours usually have yellow versus theirs. Consider hazards may be cause of cancer. So those just showing the cause. These can cause cancer. international organization for ISO safety symbols. So it's the International Organization for Standardization, so ISO. Defines designs criteria for international safety signs and standards of ISO 3864. Symbols are used more frequently in the US in conjunction with the OSHA required hazard signs, as well as in Mexico. So US and Mexico really use these about the same. First responders should be able to recognize more common symbols used to indicate hazardous materials. So we all kind of know what those mean because it's on every placard and whatever we use, it's all standardized pictures. And then you got your color code. You kind of already had it figured out, like red means danger stop, orange means warning, yellow means caution, green means safety equipment, and blue means safety information on the different markings on labels. So, like used on containers of flammable liquid, emergency stop bars, stop buttons, fire protective equipment. For red, orange, which is the warning, used on energized equipment, hazardous machinery with parts that can crush or cut. Yellow is caution, also used on corrosive or unstable materials. Also, that you can see the yellow with the black stripes or yellow with black checkers may be used to indicate physical hazards such as tripping hazards. And then green, like safety equipment, means like first aid station, safety showers, or exit routes. And then blue pretty much means you should probably wear, the required PPE on this incident. Where might you find other types of markings, marking systems, labels, labeling systems, colors, color codes, and signs that indicate the presence of hazardous materials? Facilities, maybe on containers themselves or bottles of chemicals, packagings. So can we describe the colors and numbers used in the FPA 704
That's
system?
1 through 4.
1 through 4, or 0 through 4? Yeah, 0 being what? Least, 4 being the severe, yeah. And
The red is for flammable, the yellow is for oxidative, right?
instability,
Instability.
yeah, and blue
Is for health.
health, yeah, good. So now we're on to objective 7. Describe the ways that written resources are used to identify hazards, materials, and their hazards. So even more ways for them to break down what people are hauling and carrying. So fixed facilities, they have the safety data sheets, inventory records, other facility documents, signs, markings, container shapes, or other labels. Transportation incidents, you use the ERG or other written resources. That's like the emergency guidebook, guide to aid emergency responders in quickly identifying initial hazards involved in the transportation emergency incident. Allows you to help protect yourself and others during initial response phase by avoiding and minimizing hazards. Isolation and protective distances based on conditions commonly associated with transportation incidents in open areas. Help or may be useful when applying to fixed facility locations or in urban settings. Helps identify materials, specifics, or generic hazards. Provide basic guidance on how to protect yourself and general public during the initial response phase. Does not address all possible circumstances that may associate with a hazard materials incident. Primarily designed for use at an incident occurred on a highway or railroad. may be limited value in application at a fixed facility. So most of the time, you're gonna use the ERG at the highway or railroad incident. But in very little cases, you may be able to use it at a fixed facility location. Operation level responders at the scene of a hazmat incident should seek additional specific information about any material in question as soon as possible. The information received by contacting the appropriate emergency response agency, calling the emergency response number on the shipping document, or consulting the information on or occupying the shipping document may be more specific and accurate than the guidebook in providing direction for managing the material involved. So, breaking down the emergency response book, or ERG, yellow border pages, but we all know that they can show the 4-digit UN numbers. The blue border pages, involve the name of material involved, the table, and then you have the references of, or identify material transportation placards, then reference the 3-digital guide code associated with the placards in the table of guide transportation placards digital code. White pages and orange border pages, container profiles. So cross-reference guide numbers and to the orange pages provided in the nearest circle. So using the 4-digit ID number or chemical name allows responders to locate the most specific initial action guide. What additional information sources they might consult at a hazmat incident, other than the ERG?
Nice weather.
Like NIOSH, weather, yeah.
Safety data sheets.
Safety data sheets. Okay. So, you can find some of the help like that in Google, yeah. So, as in what I was telling you about the containers, they list all the container shapes or sizes, and it helps you look up, if you don't see anything on it, it helps you know what they're carrying or hauling. Or sometimes you have the placards on them. So, the instructions are in the white pages. White pages provide instructions for use of ERG. There's 2 sections. Front section provides information on shipping documents, how to use the guidebook, local emergency telephone numbers, safety precautions, notification and request for technical information, hazard classification system, introduction to the table of markings, labels, and placards. Table of markings, labels, and placard, and initial response guide to use on scene. Railcar identification chart, railroad identification chart, the GHS system and labeling of chemicals, hazard information numbers displayed on some intermobile containers, pipeline transportation. Back section provides information about the ERG user guide, protective clothing, fire and spill control, levee safety precautions, chemical, terrorist, use of chemical, biological, and radiological agents, and provides explosives, IEDs, safe standoff distances, glossary, Canada, United States National Response Centers, United States Response Assistance Plan, or emergency response telephone numbers. So if it's a horrible chemical and you just don't know what to do with it or deal with it, they have emergency response telephone numbers in the back you can help call, like in Chemtrick or so on. So breaking it down, provide 4-digit UN numbers in the listed numerical order, so they're all going to be in numerical order. Assign the 3-digit emergency response number and the material name. So you look up your 4-digit, and then it'll give you the 3-digit guide number to turn to. Enables first responders to identify guide numbers. So if it's green highlighted, if this is green highlighted, you know it's a toxic inhalation hazard. If it has a P next to that, it indicates the material that polymerizes. Polymerizing is a violent reaction to release of great amounts of heat and energy. And then you have the blue Porter pages, and they go by provide index of dangerous goods in alphabetical order. So if you know the name of the substance or material, you can look it up in the blue pages by alphabetical order. But be very careful because some look the same or spelled very close to the same, so make sure you're looking up the correct one. And those can also be green highlighted to tell you that it can release harmful gases, and also the P for polymerization. Many HGs use the phonetic alphabet to spell chemical names. Do you know what the phonetic means? Alphabet? So Alpha, Bravo, Charlie, Delta, kind of like those. That means phonetic alphabet, or which we already kind of just know that and do that. Then you got the ERG initial action guide, which is also with the orange bordered pages. Provides safety recommendations, general hazard information, compromised of individual guides presented in 2-page format, featuring 3 sections. So on the left-hand page lists potential hazards, public safety information, so you got your health hazards and your fire and explosive hazards, and then your public safety information. On your right hand side you have, under public safety you have your initial isolation distance, protective clothing, and evacuation. With those, you can get your initial isolation distance. So you know if this spills here, you got 100 foot, you make your initial isolation all the way around perimeter 100 foot. Evacuation, isolation zone. So you know you're here, and your evacuation is side to side there, especially if the wind's blowing this way. You know, even though it says 100 foot, if the wind's blowing this way, that doesn't mean this way, that means 100 foot that way or that way. It's probably the most likely best if you're downwind. So it also has the protective clothing after you find the public safety part. And then material is green highlighted chemical and yellow bordered and blue bordered pages. So it's either consult the tables of the green bordered pages, and that's toward the back. Listed GIH materials and water reactive materials. Awareness level personnel will probably not be involved in evacuation beyond the initial phase. So describe the emergency response topic, including precautionary for incident involving fire, spill or leak, or first aid section. Several recommendations are listed under each section to further assist decision making. First aid information provided general guidance before seeking medical care. Fire section recommends the extinguishing agent to use on large fires or small fires. Fires including bulk containers. If foam is recommended, it will tell you which type of foam you're supposed to use. Recommendations vary by the guide. And spill leak section provides action to take regarding to the spill or leak. Also will provide basic information to mitigate the spill. So before attempting to conduct ERG recommended actions, you must be properly trained and have the correct equipment. So even though if you know how to use the ERG, look it up, if you're not trained, don't do it. So the first aid section provides basic steps, common recommendations including calling the emergency medical services assistance, moving victims to fresh air, flushing contaminated skin, eyes with running water or decontamination, avoiding direct contact with hazardous materials is emphasized. May recommendation provide in the section beyond scope of awareness level to provide victims before first aid is provided. Victims may present serious hazards to rescuers because they may be contaminated with hazardous materials themselves. Only responders with appropriate training, wearing appropriate PPE, should touch and handle the victims. Awareness level personnel should not handle or touch contaminated or potential contaminated victims at a hazmat incident, even to provide basic first aid. So, right there, don't touch any contaminated or potentially contaminated victims if you're at awareness level or don't have the proper PPE. ERG tables of initial isolation and protective incidents, like we've kind of gone over. The green board pages, table 1 is initial isolation and protective actions distance. Table 2, if it's water reactive materials, will produce, it will tell you what produces toxic gases. Table 3, initial isolation and protective action distance for different quantities of 6 common PHI, and in the US gas. So it provides 2 different types of recommendation safety distance. It'll do the initial isolation distance with the wind, and then you have your protective action zone. So which will be half the distance up here from your downwind distance and half the distance that way from your downwind distance. And that makes up your whole violation distance. So small spills, small spills, approximately 55 gallons or less. So if it's a barrel that's filled with 55 gallons or less, it's a small spill. Involves a single small package, small cylinder, or small leak from a large package. Large spill is more than 55 gallons. Involves a spill with large packaging and multiple spills from many small packages. So even if you can consider such that you have 5 50-gallon drums that are spilled, and now that's turned into a large spill from a small spill container. You have different daytime, nighttime situations because the atmospheric conditions can significantly affect size of the chemical hazards area. Because the pressures are different during the day and night. Warmer, and the sun's out, so the warmer, more active atmospheric common during the day disperses chemicals, contaminants more readily. Lower toxic concentration may spread over large areas. Cooler, calmer conditions at night. Higher toxic concentration may exist in smaller areas. So it's not spreading as fast at night, it's keeping it close. Initial isolation distance provided in the green pages, distance within which all persons should be considered for evacuation, and all distances from the actual hazard spilly distance will always be at least 100 feet. So it's anytime there's a spill like that, it's always going to be 100 feet to start with, and could go up from there. Protective action, steps taken to preserve health and safety of emergency response in public. People in this area could be evacuated or just sheltered in place. So if you cannot get to them fast enough, or if they've already been in there and you're able to, you can just shelter them in place instead of trying to drag them out with harmful hazardous materials. Materials with text when spilled in water following their name in table 1, consider water reactive covered in material 1. So table 1 lists chemicals provided with materials spilled in water. Table, which we went over there. We got the next thing after, so that's basically ERG. Anybody questions how to use the ERG, really? Okay. And then we go on to shipping papers. Shipments of hazardous materials must be accommodated by shipping papers that describe them. So bill lading, waybill, or similar documents that they've made up themselves to present a bill of lading. General location and type of paperwork change according to the mode. So this is they should always have an emergency contact number. A hazardous waste shipment must accommodate the uniform hazard waste manifested document typically attached to the shipping papers. So this, if it's marked HM, we'll need hazardous materials. So if it's marked here, then you know you're dealing with something that you should probably look into. And then it should also list the UN number next to it. So the basic description is ISHP, which is identification number, proper shipping name, hazard class or division, and then packaging group. When you know close to approach the incident safe, you can examine cargo shipping papers. That's if you're able to get to them, if it's safe. Information provided can be used to identify hazards such as potential fire, explosion, or health hazards. May need to check with the responding parties to locate the shipping papers. If the responding parties not carrying them, check appropriate locations. Like trucks and airplanes, papers are placed near the driver or the pilot. On ships or barges, papers are placed on the bridge or in the pilot house of controlling tugboat. Train crews should have train consist entire train cargo list, train list, and look for the train crew first. They should have the papers. If the train crew cannot locate, contact the railroad through the emergency contact number for the copy of the train list. That way you know what the whole train is hauling. Maybe a copy of a certain train list in the engine if the person doesn't have it on him. Most railroad companies count and list train cars from the front to the back. So if you're looking at the train list and they're labeling what's on it, you can see it goes from the front to the back. Alright, shipping paper information may be provided in a variety of formats such as fax and email. Transporter shipments between the U.S. and Mexico may be accommodated by shipping documents, and they have to be both in English and Spanish. So you could grab one and it's in Spanish, try to look to see if there's another one in English, because if it's going across borders, it has to have both. So don't just give up if you pull the first one. You're like, oh, I can't read that. Look to see if they have an English one. So here's kind of what your safety data sheets look like. This is from Hansen. So you got your ammonia anhydrous as your product identifier. Detailed information bullet prepared by the chemical manufacturer and importers. Provides specific information about the product, formatted according to the Global Harmonized System, GHS system. Often best sources of information about a particular material in which emergency responders have access. And if you don't can't read theirs very well, you can contact the manufacturer of the material, supplier, shipper. Emergency response, you can always call Like I said, at the back of the ERG, you don't know what you're dealing with, you can always call Chemtrek in the back, from the number in the back of the ERG. That'll help you identify, if you can't read their safety data sheet, what you're dealing with. They should also list on there the potential hazards of fire, explosion, and health, and precautions to be taken for the responders. So section 1 of safety data sheets should have identification. Section 2, hazards of identification. Section 3, composition information on ingredients. Section 4, first aid measures. Section 5, firefighting measures. Section 6, additional release measures. Section 7, handling and storage. And Section 8, exposure controls, personnel protection. Section 9 is physical chemical properties, identifies physical and chemical associations. Section 10, stability or reactivity. And then, which is kind of broken into 3 parts, which is reactivity, chemical stability, and other. Section 11 is toxicology information. Section 12 is ecological information, or I guess toxicological. I can never say that right. And then section 13 is disposal considerations. Section 14 is transport information. Section 15 is regulatory information. Section 16 is other information. So that's kind of how a safety data sheet is set up. As in for transportation information, like road, air, sail, or rail. And then you have your facility documents. Hazard. So you got your chemical inventory list. Usually contains information about location of materials with the facility. Can be a useful tool to identify containers that may have damaged or missing labels or markings. Several other documents and records may provide information about hazardous materials at a facility. Shipping and receipt documents, inventory records, risk management and hazardous communication plan, chemical inventory reports, tier 2 reports, and facility pre-plans. Local emergency response plan, designed to provide forum for emergency management agencies, responders, industries, and public to work together to evaluate, understand, and communicate chemical hazards and communication, and also develop appropriate emergency plan in case chemicals are accidentally released. These are called local response plan. And then we go to, last but not least, the electronic technical resources will be the last of our ways to identify chemicals. So you got mobile weather apps, which we use here to say if you can burn or not burn, but it's also good to, if you're going to hazmat scene, to know what the wind is doing. So and then you got Cameo, which means computer aided management of emergency operations, designed by National Oceanic and Atmospheric Administrators, so NOAA. Systems of software application helps emergency responders develop safe response plans, can be used to access, store, evaluate information critical in emergency responses. So that's Cameo. And then Wiser is a wireless information system for emergency responders. Electronic resource that brings a wide range of information to a hazmat responder. So it can give chemical identification support, characteristics of chemical and compounds, health hazard information, contaminant advice, available in different formats depending on the operating systems, and may be downloaded free of charge on any device. And then there's the 911 toolkit. The 911 toolkit is only available for Apple devices. So Brandon, you are out. Provides a variety of information that may be useful for first responders, as in like hydraulic situations, water delivery, EMS, hazmat, NIMS, ICS, checklists, and it gives quizzes as well to help you out to gain better knowledge. Then you have your hazmat IQ e-sheets, which is like a training course that you can continually use to keep yourself up to date on all the hazmat stuff. And it is available for Android and Apple devices. Identify this, using resources to transition to planning the incident. Identify the substance. Use sources to gather information about the physical and chemical properties. And like we talked about, the ERG, shipping papers, SDA, pipeline operators, computer apps, phone apps, placard and labels, and manufacturers. You can use all those to figure out what you're going up against in the hazmat incident. Additional information gathered, sources may include, just with all those, like we've talked about, potential hazards, signs of symptoms exposure, responsible party contact information, precautions, safety handling and control measures, emergency first aid and procedures. What are the sections of the ERG and what information do different sections contain? Yellow is numbers.
Blue is the words.
Blue is
Or the name, yeah.
alphabetical and the name of the chemical.
Green for polymerizer and.
Yeah, so if it says P, polymerizer, have it distance that, and water reactive, and what's orange? Your guide gives you all the info.
Your instruction.
Yep. So what written resource other than the ERG are first responders most likely to utilize?
SDS.
And why? SDS shipping papers, because most readily we see, what railroads or transportation in other ways that'll have the safety data sheets. So lesson summary: students should know how to use the API process on the hazmat incident, identify states of matter related to the hazmat, identify 7 clues to the presence of hazmat, how to use placards, labels, and markings to identify hazard materials, how to use the ERG to identify and initiate protective actions. So, are there any questions about any of this content? Okay. So, now we're going to hand out a quiz, and once you are finished, I'll have you go ahead and step out the side for me, and then I will call you back in once I've graded your papers and let you know how it went. Do you need a pen? You need a pen?